Okay, hi guys. So in this lecture, we'll be seeing more example of diazotization of amine and the forming alcohol as a result of N2 gas release from the diazotized compound. Okay, so let's get started. So our first example is we have something like this, and we are passing it in presence of HNO2. Okay, so obviously we'll be getting NO plus, and then we'll get something like this as diazotized. Uh, Diazotization took place, okay, of the amine. Then what will happen is, in presence of water or any other acid, what will happen is we'll get positive charge here, okay. And now this water will act as an electrophile. Before acting the electrophile, I think the rearrangement is possible in this reaction, and we'll be getting something like this, okay. And then water molecule and can act on the top of it to get something like this as the final product. Okay, let's make OH here. Okay, second example is, obviously we are having CH3 OH here, and CH3 and CH3 here, and NH2 here. Again, in presence of HNO2, what will happen is we'll get diazotized group here, okay. And then what will happen is we'll get a positive charge at this carbon atom, and we'll get something like OH here and C positive charge here and 2 CH3 here. Next, what will happen is rearrangement will happen, okay, and in which this CH3 minus will rearrange itself onto this carbon atom. As a result, we'll be getting 3 methyl group here and a CH3 here, positive charge here, and OH here. What will happen next is, obviously we'll be getting ketone at this carbon atom. Okay, next let's see another example wherein we have something like this, okay, OH and NH2 here. Again, in presence of HNO2, what will happen is we'll get something like this, okay, and plus and here. So what will we be getting? We'll be getting, again, in this will be taking away the bond, and as a result we'll be getting positive charge here and OH here. Again, this will be getting double bond between oxygen atom and the carbon atom with the release of H plus, and we'll be getting this compound. Okay, so with this we come to an end of the diazotization of amines concept. Now let us actually move on to seeing Demjanov rearrangement. Demjanov rearrangement, okay. So suppose we have a compound like this, okay. Now what actually happens here is rearrangement can take place, okay, and we can get something like this compound, or we can get again this bond can shift here, and we can get positive charge here, double bond here. So this actually remains at 48%. This comes to 47% in after the rearrangement. So I'm just telling you the percentage of how much they actually occur when the rearrangement actually take place, okay. So let's say we have this compound, or let's say we have NH2 here, okay, attached to this CH2, and this is reacting with HNO2. So what will we be getting? We'll be getting something like this, okay. Then what will happen is we will get something like positive charge on this carbon atom. So we'll be getting this compound, and this compound in the, and what will be the percentage of them? Again, the percentage would be 48%, 47%, and 5%, okay. So this is Demjanov rearrangement, okay. So Okay, one more interesting scenario in the rearrangement process is, suppose we have something like this, okay, and OH is attached here, okay. Let's say there's a positive charge only here, okay. So now one might think that 6 to 7 rearrangement is not possible and will not take place, but 3 to 4 to 5 to 6 will take place, but 7 to 6 will not take place, because from 3 to 6 the ring strain is actually decreasing, and hence it will move forward from 3 to 6, okay. But sorry, 6 to 7 will not take place, because again 6 is the most stable according as far as the ring strain in all the carbon atoms is concerned, and 6 to 7 will not take place. But in this case 6 to 7 will take place. As a result, what will we be getting is, we'll be getting something like, obviously this bond will be breaking up, and here we'll be getting a positive charge, so the resulting compound would be something similar to 1 2 3 4 5 6 7. So resulting compound would be having positive charge here and OH here. So what will happen is, this is the formation of our highly stable IIT cation, wherein positive charge is attached to that carbon atom on which oxygen atom is also attached. So we'll get a ketone formed as a result of that. Hence in this case 6 to 7 rearrangement ring is possible because of the formation of highly stable IIT cation. This will actually shift the equilibrium into the forward direction, okay. So with this we come to an end of this lecture. In the next lecture we'll be seeing heating effect, okay. So till then, good luck and goodbye.